Operators are looking for alternatives for GPS synchronization primarily because of what's called HETnets, heterogeneous networks. And so macro base stations, the traditional ones that you're used to from sitting on top of a building or on top of a tower, they usually have easy visibility of GPS satellites. And they're in secure locations, so nobody can tamper with the GPS receiver. So I think that actually remains a very viable technology, primarily in the United States. Outside of the United States, there's a lot of countries that are reluctant to totally rely on GPS because it's a US government-controlled satellite network. And so they are actually started moving to IEEE 1588 for synchronization earlier than in the United States. The other reason is with the increased coverage and capacity requirements for LTE, in particular in urban canyons, in urban environments, in big cities, you actually need something which is called picocells as well. And a lot of people talk about outdoor picocells, but actually even more so, you will actually need indoor picocells in large office buildings to actually provide coverage, but also capacity for office workers in big buildings because it's a highly concentrated area. A lot of the LTE frequency allocations do not penetrate walls very well. So you will need those picocells both in indoor and outdoor environments. They usually are outdoor picocells are at street level, so they don't really have a lot of visibility to GPS satellites. And indoor, again, you really don't have GPS coverage indoors. And so that's really what's driving packet timing technology as in IEEE 1588 in these heterogeneous networks, HETnets.